CNN classifier on the same satellite images to classify the river and non-river classes. So actually, the objective of this hands-on session is that not only to get acquainted with this Python programming, because Python programming, I think you can also do more practice on it by yourself. But the thing is that unless or until you understand this algorithm, how it works and what are the flow of the algorithm, then it will be difficult for you to code it. So that's why my intention was in the hands-on session that is fine that I can share the code with you and then you can just implement it. But how the implementations procedures will work? Okay. Now, if you just understand the implementation procedures and if you can digest that, yes, if you can follow these steps and then I can get these results in a more effective way, then obviously that all of you will be able to implement it. And as it is a very important, I mean, FDP or this is a workshop for practical things that is more required, because whenever you are going to learn this any algorithm, any ML algorithm or DL algorithm, unless or until you implement it, then it will not be digested. Okay, that's why my intention that I give it to you this idea about you can implement the base tool on the satellite images if you know the steps, implementation steps, only to call these libraries and inbuilt functions. Okay, I mean, yes, inbuilt function is fine because no need to write this code. But sometimes if you know this, what is this going on inside this any inbuilt function, then if you understand this, yes, so this are exactly going on within this inbuilt function, then it gives you an more interest, okay, to explore future in some other way. So anyway, so that is the thing. So you can just see this implementation step which I have written for you, so that it will give you some interest in future also to take up it as an assignment and to implement it by yourselves. Okay, no need to take any help from other way also. So now that I'll also see that I'll also explain you that for this KNN I have already explained it in my theory class. Now how to implement it, that on the same satellite images, and I will get this some different results which may not be good. That the results that you have obtained in the base rule that you have seen already. Now we'll check on the same data set how much accurate results that KNN will produce. Now let us start. What are the steps to follow? That is, first you have to read the images. Now you are going to have you are going to have these 4 satellite images in R band, G band, B band and I band, which are given to you. Now you have to read each image, okay, and store the each band pixel value in separate column in a data frame or a NumPy array. More specifically, that this illustration is given for you, so that you can easily read these images and you can store these intensities values, because mind it that you are going to solve this k-means cluster, this k-nearest neighbor algorithm. So this store these R band, G band, B and I band pixel values in separate columns, okay, in a data frame or a NumPy array. Now your data set will have 4 columns corresponding to R, G, B and I, and each is 512 to 512 rows. Okay, so that is a total pixel values, very fat matrix that you can get for each column corresponding to each band intensity values. First column corresponding to R band intensity value, second column is a G band, third column is a B band, and fourth column is I band. As this intensity, as this image size is 512, that has to be is 512 to 512 rows. Now you have to normalize your data sets. Okay. Now this after this normalization, so now you have to select the river and non-river points the same way that you have to choose. Now we have to, you can use the open the image point paint and select this 100 coordinates from the river part of the image and 100 coordinates from this non-river part of the image. And find the corresponding normalized RGBI values from your data frames that which you have already stored it, and you have to store the river and non-river values in separate data frame for this array, because in these separate data frames, so here only this coordinate corresponding to these coordinate positions or the pixel coordinates, so that values will also be stored there. Now you have to classify all pixel in the image into river and non-river using this KNN. Now for each of the 512 pixel, you have to calculate. What you have to calculate? You have to calculate this equilibrium distance. Okay? You have to calculate this equilibrium distance between the corresponding RGBI values of the pixel and the values. Just see, corresponding to RGBI values of that pixel. I mean, this image that you are going to choose, this is called test image. Okay, because you have to choose a test image, and all the pixels which have already stored it for the corresponding class. Okay, and this between the corresponding RGBI values of the pixel and these RGBI values of all the selected pixel from river and non-river class, which you have already extracted and you have stored in a data frame. So the same process that if you have this, here you are going to solve two class and taking this 100 points, and one class you have in this 100, another piece also is 100. So total that you can have for each class. For if you are going to have 1 points, for 1 points you have this 100 points, and that is a things that is very important in this case, that how do you require it, and it will be useful for this case. Now somebody has asked a question, that is why this normalization is required, because actually for this problem, so it is not actually required for the normalization, but whenever you are going to have other images and where these normalizations will help you to understand, that is if you have this 0 to 1, if you are just going to have in the range of 0 to 1, or you can do this normalization with respect to the mean normalized image that you used to have, that is you just have this x, you take the x minus mean divided by the standard deviation. Okay, then you can have this mean normalized images that you can have, which will have the same scale that you are going to have. But here in this case we are also using have this sense scale, so it may not be required for this case, but actually when you are going to use some data processing from these other images also, and for the different dimensions or this different way, or this if your intensity values in the range of suppose to 24-bit images that you are going to use, then that may that at that time it may be required for using these normalizations of your data sets. So but for the present moment, that as you're going to use 8-bit images and your intensity values in the range of 0 to 255, so you can do it, you can just make it as 0 to 1 scale also. Okay, or you can just simply use a mean normalized images with the range of x minus x bar divided by standard deviation. Then you can find a mean normalized image, and from the mean normalized images you are going to take as a test images and do it for the other way. So it will also be useful for it in some cases, and will also give it to the very good understanding, and it will help in the computational process. So this way that you can have, we can store the river and non-river values in separate data frames. Now you have to classify all pixels in the image into river and non-river using a KNN. How you are going to do it, that I will explain to you. First, you calculate this equilibrium distance between the corresponding RGBI values of the pixels and these RGBI values of the selected pixel from river and non-river class. Now you have to sort the distance values in the ascending order. Okay, and find the class corresponding to the k nearest neighbor data points. We have to choose the value of k, if we are going to choose 3 nearest neighbor. For this case, the steps that for these satellite images, so I'm going to choose k is equal to 1, k is equal to 3, 5, 7, and 9. So total, how many? 4 images, 4 output images, 5 output images I'll get. Now, based on the majority voting, you have to assign the class to the corresponding pixel. So here, this is majority voting based on that what are the maximum number of class representative is there based on the distance values that you have already calculated. So if you're going to have this 200, then 200 distance values. If you're going to have for the both classes, then among them that what are the maximum class representative that you can choose, then you put it in this particular class, and based on the majority class, then assign the class to the corresponding pixels. And if the pixel is classified as the river class, then assign it to the color white. Else, for this non-river class, you assign it to this black. So now for pixel 00 to, now you have to make a pixel 00 to pixel 512 into, I mean, make a pixel from 512 into 512 and take these RGBI values corresponding to pixel I comma j and make a feature vector for the 100 pixels in river class. Okay, you have to just use it. That is only 100 pixels that you can take, and find the distance between this feature vector of pixel ij and the feature vector of the pixel which is stored in the distance of the array along with the class level that you already calculated. Now for these 100 pixels in these non-river classes, we have to use the same procedures. You are applying this distance this between this feature vector of pixel ij and the feature vector of the pixel stored in the distance in the array. I mean, the same process that you need to follow, and sort the distance array in the ascending order. And you have to take the first k elements in the array and note their corresponding classes, means what are the class representative that you could find. And you have to, and the class who appears more than k by 2 times in the first k entries, that will be the class of this. I mean, here you are choosing this majority class. This is a majority portion that which one is appearing this maximum time. Then this class of this pixel, then you have to take the first k entries, first least distances. Now out of the least distances, what are the maximum class representative is there, so that you have to choose. Now if the class belongs to the river class, is assigned to color white in the output image, or assign the value to 555, and I mean for this each band, or you have to make this 0 for the corresponding, else you have to make it 0, means 255, 0 or 0, 255 and or the black. And or you can store this in the 1D array with the three pixels in I comma j position, and this output as a as the image array. So that's how we can use it as an 1D array. So 3 pixel values that you can get, that is in I comma j positions, and then output image array. And finally, after completing the above steps for all 512 pixel, you have to display this output. So these are the steps that is to be implemented, and these are the how the things can be done. So I have already explained, so there is no need to explain it. Finding this never that, and you have to apply this majority voting techniques, and you have to take the k points whose distance is smallest from this point, and these k points are this k nearest neighbor and this class level of the k nearest neighbor to be found out based on the majority class. So these few points that is to be noted, that is already I explained it and already shared this PPT also. You can just refer this PPT. And an integer value, that is we can take, that is a integer value k, and which is the number of the nearest neighbor, and the samples or data points whose class level is already known. So you have to calculate the distance matrix to compute the distance between a new data points whose class is unknown and sample whose class is already known. So if k is too small, that is I already explained, that is a the algorithm will be sensitive to noise point. If k is too large, this neighborhood may include points from the other classes. Okay, and there is some scaling issue. That is you attribute or the features is may take different range of values. For this also this normalization is required. Okay, because as these things is a very features, because if you are going to use some other not images, some other one-dimensional data or other things, so there is a different range of values. If you find, then there will be extremely difficult for you to do these things, to do the process and applying these things. So that's why also normalization that I was explaining to you. So there is also another for the scaling issue that we can use it. And so they should be scaled or normalized to prevent the distance measures to be dominated by any attribute whose range is higher. So it may so happen that if you see some outlier detections, that if the point is deviating from the mean, okay, then how much deviation is there? If you would like to capture, you make a threshold value. If the crosses the threshold, that we are not going to calculate. We are not going to consider this point as the actual point within this periphery of this. I mean, within this periphery of this mean. So that is the issue for this, to avoid this scaling issue, or to prevent that it should not be influenced by these other values, which are these higher values or high intensity value from the current one, or which should not be dominated by. That's why we need to have the normalization also. And the majority class, the k-nearest neighbor each have their individual class levels, and the majority class in the binary classification will be that class that appears more than k by 2 times as per the thumb rule in this k-nearest neighbor. And these now when I implement it and we observe that, so there are a lot of things there. When k is equal to 1, this image that is output image. Now you can check that this base output of the base decisions rule that we have obtained and output of the k-nearest neighbor rule. So as I already told that this error rate, obviously it is a base rule is always optimal decisions rule. Okay, but this although it is also derived from this base rule, but this error rate, this that is will be a twice of the base error. That is a thumb rule that I already explained it. So there is a lot of pixels now that is a probability of the misclassification is large, as you can see. That is a many pixels, many white pixels. When I choose k is equal to 1, then these many pixels which has been wrongly classified as a non-river classes, which is actually belong to the river classes. So due to some this distance measurement issues, how they are going to calculate, or few points are more similar, and this is very difficult to take. And if you are going to choose a very small values of k, it is sensitive to noise, as I already told you. That is the reason that for k is equal to 1. Now if I am going to improve, that is a just increase this k is equal to 3, so some improvement was occurred. Then k is equal to 5. Just see, when I just changing just k is equal to 5, then image after applying the k and 5, then it is a moderate. Then obviously this misclassification error that we have obtained from this previous one for k is equal to 1 and k is equal to 3, so it is better than, now it is better, because here this misclassification error is lesser for choosing k is equal to 5 than misclassification error which is produced in k is equal to 1 or k is equal to 3. Now again, if you have just improved k is equal to 7, now there is some more improvement has been observed. Okay, so it up to you that what should be this optimal, because there is no as such thumb rule to choose. Yes, if I'm going to choose k is equal to 7, I may get these good results. But in this case, you can just keep on applying and to choose this best. This choosing this best case, that you simply do the cross validation method. So this cross validation, it is nothing but that I'm just going to explain. So what actually this is a cross validation. So this you are going to have a suppose I'm going to have these 200 data points. Suppose so one of the way to choosing this case cause suppose I'm going to have these 200 data points. So it is my set. Now these 200 data points uh, can be divided into 10 sets. So I'm going to have 10 sets. So each sets will have 20 data points. A1, A2. So A1, A2. I'm going to choose A3, A3 till I'm going to have A10. So this is my 10 sets. Okay, each sets will have this equal number of data points. So total 200 data points are there, and this is a 10 set. Now what I'll do, that is I'm going to take first, this is a 10-fold cross validation. Okay, my k is equal to k-fold cross validation, then this is called the 10-fold cross validation, k is equal to 10. Now my a1 that I'm going to use as a test sets. So I'm going to use as a test sets. Sorry, I'm going to use as a test set. I am going to use as a A1. I'm going to use as a test sets, and A2, A2 to A2 to A2 to A10. This is my training set. This is one fold. Okay. Then you can take A1 is a test set, A2 to A10 is a training set. Then you apply it for k is equal to 1. Then k is equal to 3, k is equal to 5. Then you can find some accuracy that you can observe. Now, next fold you can take for A2 is my test set. I can choose A2 is my test set, and I can take from A1 union, A1 union, I can take A3 union, A4 union, I can get A10. So this is my training set. Now you can get another classification accuracy and the misclassification accuracy. Similarly, you can go on. So this is one fold, this is another fold. Then finally you can have A10. A10 you can choose as a test set. You can take A10 as a test set. Okay, and you can have A1 union till union A9. So this is your training set. So for each fold you are calculating this probability of misclassification error. In the first one, suppose for k is equal to 1, 3, 5, this way, and for each fold you are taking this probability of misclassification error, and in which fold it is giving that I mean, you can also observe you are going to use the 10-fold cross validation. Okay, so for each fold, and you are going to choose. Suppose for k is equal to 1, you have done it. Suppose k is equal to 1, you have done it. All the fold you have calculated the misclassification error for all the folds. Then you are taking this mean and standard deviation, mean of the misclassification error and standard deviation of the misclassification error. Calculate it. Okay, then for k is equal to 3 you can calculate mean is something like that. Suppose 0.001 or standard deviation is something 0.2. Okay, so you are going to have this different way. For k is equal to 1 you have a different mean standard deviation. For k is equal to 3 from different mean and standard deviation. Now which one will give it to this which now question comes which k value I choose. You'll have to choose that k value which will produce this minimal I mean this your mean is less and standard deviation is also less. Then this fold, I mean this k value I am going to choose. This is a one way of doing this. Okay, you have to choose the mean of, I have to choose this mu mu is called the mean of misclassification error probability for all the. So how many misclassification you have to take this mean of this misclassification error probability? 10. So you have to take the mean of the misclassification error probability and sigma. Okay, now this mean is called the precision. Okay, and this sigma, that is, you can see, that is all variances in square. This is called the variances. You can take this, that is called is your accuracy. So that you can find. Okay, so this is a way, another way of doing these things. So if you can calculate this mean and standard deviation, then you will see, yes, so this results that you can find it for choosing the best k value. So these things, so that I have already things. Now I'll explain it. This portion, that is, you have already seen how to implement it in KNN. That is a iris dataset. Okay, so load the dataset, split the data, and then you have to define the. So these are the steps. So that I'll show you this Python code for it, so that you can do it by yourself also. And first you have to load the data, same procedure. You have to split the data set into training and test. You have to define the custom KNN class. You have, for the similarity measurement, you have to use the equivalent distance. Then predict. You have to do the prediction using this majority vote. Then you evaluate all these things. So let me show you this code for it. And this is this KNN code that you can see. Okay, that is a, you have to first import these libraries, that is a numpy as np, then sklearn, all the library, that is iris dataset, then train test selections, so that you need to do. Then finally you have import this classification report, where in the classification report you have this other metrics, standard matrix, precision, recall, and information that you can have, and this accuracy score. And you have to first define the custom CNN class. Okay, so this are the way of doing it. So we are using this k is equal to 3, but you can also change this k value, then accordingly this custom KN class can be defined. Then we are going to have X train and Y train, these two things, because you just I already explained in the first, in this morning lectures. So there is a one data set was also given. So you can also test this data set on X and Y. So X is a feature vector or some sample points, 10 sample points was there, and Y was your class level, so positive class and negative class. Now there is a point, that is a test point X, that is 0.5. You need to apply 1 nearest neighbor, 3 nearest neighbor, 5 nearest neighbor, 7 nearest neighbor, 9 nearest neighbor to classify. So just simply way, there is a extend and alternate. You have to predict for this prediction, that we have to use it. That is a numpy np.array prediction. Then you have to do a prediction single, that is a distance. Okay, so this distance function, where compute the equivalent distance to all training points. It is already how to calculate the equivalent distance. So these are the I mean, a line of code which is written, and you have to get the indices of the k nearest neighbor. That was, I was explaining to you, that is a k1 is how many points, k2 is how many points. This is called the k indices, k3. So based on this, I mean, or on the other, you can see you have to sort these all the distances in ascending order, and for each values, the sorted values is being denoted by the key indices, and get the levels of the key nearest neighbor based on that is a what are the class belongingness of this pattern for the corresponding class, and you have to return this most common level by using this majority voting. That is been done. Now you have to load, first you have to load it iris data, the same command, that is iris is equal to load iris, and then xy. X is your data points, iris dot data and iris dot target. Okay, you have the class level. then split into training and test. This X train, X test, Y train and Y test. So the same process. You have to train and evaluate the custom KNN model. Then your model will be custom KNN k is equal to 5. That we need to test it. And model dot fit, then X train and Y train. Then you have to predict. I mean, first you have to develop this model, then you need to test it, or you need to predict it, that whether your model is giving this correct accuracy and correct performance or not. And then you have to evaluate this model, like this classification report that is already shown. And more or less that if you can use this iris dataset, so that is also giving you this very good result on the iris dataset. But if you can use some other dataset, so here then you can use, if you just check this range of the data. Now if there is a problem of this scale and this there is a huge difference between these data points, then you may apply the normalization techniques. This normalization technique may be used for you. Min-max normalization technique, you can simply use it. And also after doing these normalization procedures, so you can just apply the algorithms, KNN algorithm, which I already explained, and you can easily get these results. Actually, someone is telling there no, okay, code is not. So okay, I'll just show you this. Let me just share the code again. Okay, so can you just see this code? I think.
Yes, sir. Yes, sir.
Okay. So okay, now you can check. So this is this code that how to import this. I'll also share the code with Professor Hans. Okay, so you can get it from share also. So this is a step 1, that is a import these libraries, that how to import it. So this is the same code that has been written for your base, in the base also, that you can check. That is we have written the same code, and that is you can check. And you can just define this custom KNN class. So these are the second step. Okay, this second step, as for the in the PPT which was written, I'm just following this PPT. That is all the steps is given: step 1, step 2, step 3. We're just following this step. Step 2, that define this custom KNN class. Okay, and then here extend and Y trend. Then you have to do a predictions for this X test. Then here you have to calculate this equilibrium distance to all the training data points. Okay, that is how to do it. So the formula is already given, you can refer to this formula. Then you have to get the indices of the k-nearest neighbor, and this then finally you can get the levels of the k-nearest neighbor based on the indices, based on the nearest neighbors, or these least distances. Or if you have this k1, k2, k3, if you have this k3, if you are choosing k is equal to 3, then you have to choose that what are the class representative for what is the k1 value and k2 value and the k3 value. So this indices that is being obtained from this way. And finally that most majority, after applying the majority voting technique, so you can finally get the labels, that is what is the class belongingness of this pattern, that you can get it. Now how to do it? First you have to load the iris dataset. Iris load iris, then iris dot data and iris dot target. Then step 4, then you have to split the training and test, train and test data in this way. Then you have to train and evaluate this custom KNN model. This custom KNN model, so you have already implemented, and in the this custom KNN is already defined over here. You can check here this what is the custom KNN. So we have to call this custom KNN. When are we going to call custom KNN? So all the things will be used, and accordingly you can get this value. First you have to train it here. For the custom kernel k is equal to 5, then you have to do this model fit. For first you need to train this model, then you need to evaluate it. We need to evaluate it, this performance, model performance, and finally you can report this classification accuracy and along with some other metric using this confusion, not confusion, I mean you need to have other statistical metric that is being reported, which is recall F1 measure. And as this is a iris dataset is a very refined dataset, and I was explaining to you that if you are going to use some other data set, you may not get this result. Suppose you can change these value of k, and changing the value of k, you may get some other results which may not be suitable for you. Then sometimes this normalization is also required in this case. Then you have to check that what type of data that you are going to use, whether it is really important for in your case, and to check to use this k-nearest neighbor, you need to see what are the range of the data sets and whether it is really important to apply KNN. So all sort of things that needs to be understood to apply this any classification technique. Thank you so much for your kind attention. And if you are any questions regarding this implementation steps, and then you can ask me, or you can I will just share with you this code to sir, then he will just share it. And so it's better to implement it. Otherwise, I mean, only seeing is will not work. So take a very simple one. So that's why we're taking this iris dataset. So iris is a very commonly used dataset, and you can get it from UCI machine learning repository, or if you just download it, this all the packages, then you can easily get it from there. So no need to install it from there. So thank you, sir, for this opportunity to discuss.
Thank you, sir. Thank you. So continue 4 hours in between 1 hour break was there. So today it was very hectic for you.
No, it's okay, sir.
Thank you, sir. Thank you. Thank you very much. Thank you for this good lecture. Both. Thank you very much, sir. Thank you.
Okay, sir. Thank you, sir.
Thank you. Thank you, sir.